Yes, welcome to this simplified overview of Siemens controller. Basically, I want to introduce to you some of the configurations on Siemens, then how can we write a program or operate Siemens controller. So this is basically a guideline on how Siemens controller operate. I like using Siemens controller from the Sinumerik. We have the Siemens 808, Siemens 802, Siemens 810 and Siemens 828. I think in the current series we have Siemens 840 and Sinumerik 1 for turning and milling operations. So all these controllers, I'm going to guide you, only one controller. I'll be using Siemens 828 to guide you on how to do programming, very simple, and how to start. As simple as that. So let me go direct to the manual operation. So this is the controller. Then once we finish that, we'll come to do a simple program. Maybe I'll select a simple drawing. We'll do a simple part program. Let me use this one. I'll use this one for demonstration purposes to create a program for this. And then we'll create a program for that. Then we assign all the operations that are needed for this. So the first procedure is always you do what you call machine startup procedure. You have to power on the machine located on the machine control cabinet. So normally on the machine control cabinet has a switch, but before you do that, you have to switch on from the mains, then switch on the power from the machine controller. Then once you do that one, you have to either ensure that the emergency button are pressed in, so that when you're switching on the machine, you're able to it is safer for that case. Then from there you finish, you have to do reference approach, check the machine status. Then from there you do what you call warming up. You can warm up your machine between 15 to 30 minutes before the machine stabilizes the temperature and it proceeds what is required. But the current machines, maybe if it has the safety aspect of it, so you don't need to do much of the setup. So we will start with our presentation on how to do this. So let's go direct to our controller. I'm assuming this is the controller I'm going to use. This is Sinumerik 808D DT for turning. That is the DC, the 800D series for T turning. So once you have the machine, ensure that you switch on from the back, and then switch on the screen. Now it has a button, so you click on switch on. The machine comes on. Remember, as I said, the emergency button should be in, so you let the emergency button should be in. Then you can now release it. You release the emergency button, or you can press this reset button. So this is the controller, machine controller panel for Siemens 828, which is almost as 840 and 808. The difference is about the configuration of the program. Okay, so I'm assuming this is your program for Siemens turning, and then for controller 828, ensure you switch on the spindle start button and the feed thread start button. Activate them. Then you have the key. You can put to 0. Ensure that you put to 1. It is aligned to 1, not to 0. It's aligned to 1. Then this is now your controller. Then the second step, we have said, if you look at our guide, is once you switch on the machine, you release the emergency button, then you reference. So you need to do what we call reference approach. So let's go to our controller. This is our controller. We do a reference approach. How do we do a reference approach? So ensure you press this reference button, and then once you finish, you press on this reference button, click on this Z. You can click on Z, and then click the positive axis, hold on. Once you see it gives you 0, it's okay. Now also, because it is XZ machine, is a LED machine, also go to ZX, then press the Z button. Always when you're hopping on Z axis. You see now the controller here, it is 00. It has been referenced to 0 point. Even the master spindle P1, it is also referenced. This is our master spindle P1 referenced. This is the how you do it. And then we are following the step. Once you reference, check the machine status. Wherever all the axes have reached the reference point and there's no error on the display. And then you can now do warming up. So let's go to those steps. There's no any error here giving on the machine. In case it is there, you press reset button to remove it. Then next we have to home our machine. I don't want to home it within the 15 minutes, but I can home it within a short period of time because it is just a simulation. Then click OK to close the door first. We want to reference our machine, so I want to reference it. So what do we do? Once we finish referencing, next we want to home we want to warm the machine. warming the machine. So how do we do it? Now click on jog mode, remove the reference, click on jog mode, and then you can go to machine mode here. This machine mode, ensure that you pick TSM or TSM. For example, I can pick N tool, let's say tool 1, and then go down, pick, maybe I can pick the maximum. There I may put 5,000 for example, maximum speed. I want to put 5,000. You click input, go down, come here. You see this one, it has gear selection, so you can pick the gear selection. You can pick this icon, you press this one, let me auto, and then spindle speed. I can put it, I can select that one clockwise. I can put this work offset maybe G54 for example. Machining plane, I want to put G18. This other function I can leave the way it is. Once the door is closed, TSM, then you click cycle start. Cycle start. You will see the spindle starts rotating. That is what we call, you are homing the machine. Now we are warming. We are warming the spindle. So you can warm it with the highest speed that it has, for example, highest speed, and then you can now start reducing it slowly by slowly. The speed, you can reduce it slowly with time, and then you to allow it at least to balance the temperature before you now start using your machine. You see, this is now the speed override. This is a speed override which can help you. As you see, when I press the speed increases, depending on the maximum speed I have put here, 5,000, so they can range within that. Then, in case you want to stop, ensure that you go a bit to be down, and then the minimum is 50, then you click reset button. It can stop the spindle from moving. So we have done warming of the machine. So next step we go is on manual operation. We want to understand the manual mode of the Siemens controllers. So these are the most of the manual operations. We have what we call the jog mode. The jog mode is normally when selecting the is a selector button. When you press it, it allows you to move the controller, the axis manually. You have what we call the axis selection. So we are going to look at the jog mode, axis selection, tool movement, feed rate adjustment, and spindle control adjustment. So let's go to our controller. We understand this now. The jog mode is this. Jog mode also always operates when you want to go manually, maybe edit the program, maybe you want to move the tool or measure the tool, move the tool from point A to point B. For example, if I want to move my Z, I can click on jog mode and then click on Z, then I click on Z negative, for example, or Z positive. It goes Z positive, for example, like this, or Z negative. As you can see, maybe let me minimize this one. I can even open the door for this. I want to minimize this so people can see this one. So you see, if I press positive, you see it is going towards positive. This is positive. Z positive goes away from your left hand. Then if you press Z negative, it goes towards your spindle. Or Z positive goes away from the spindle, then Z negative goes towards the spindle. Then you have also X. You press on X, you can go X negative. You see, X negative goes away from you, X positive comes towards you. But the origin or the center point is normally at this line and the center line. So this is how you can move where you're using jog mode. Then you have the teach in or teach pendant. You have the repositioning of the spindle. You have the referencing point. These are the point when you want to reference or move your tool to a home point. You use what you call ref point. You can use MDA or MDI. If I want to go, maybe for example, I put G, let's say G00, and then I want to put G0, and then space a little bit. I want to put, I want to go to X, let's say G01. We put G01 or just X10, for example, X10, and then I put cycle start. You see the tool goes that direction. It goes to where X10 is. If I want, for example, to move, let's say Z10 or Z2, and then I press cycle start, you see the tool goes towards Z2. Yes, this is now using MDA. MDA allows you to go direct to a point where you want to go, or even to start a spindle manually. For example, I can even remove this one, and then I say, for example, go home. Let's say, because this is Siemens 808, I can say it's G75 space G0. Put here G0 space. I can say maybe X0 space Z0. Sorry. Let me go one by one first, and then I click cycle start. you see the machine will go towards 0 point when I'm set my tool where the 0 is. That is using G75. I can even remove it, this one, to say I want to go, let's say M0, let's say I want to start a spindle M03, for example, space spindle speed with maybe 200, for example, that one. Then I say cycle start. You'll see the spindle comes on automatically, then start rotating. So these are functions which I help you to move to a point where you want. We call them MDA or MDI. Then auto mode, automatic mode is a command that is used when you want to move to now either do tool change automatically, or you want to load the tool, or you want to for example, you want to now cut your part automatically. Then it has this incremental from 10, 100, it starts from 1, 10, 100, 1000, 10,000 increments. So you can use those increments when you're cutting. Then you have the coolant. If I press coolant on, ensure that it is on the joke mode. If I press the coolant on, the coolant comes on the spindle, as you see from the pipe. The coolant comes on. It can be either from the through tool or from the pipe, depending on how your machine is. This is for lighting. If I put on lighting, the turret comes lights here. If I put on a chuck in, you can see this is a lighting. Then you have the spindle clockwise. For example, if I click on spindle clockwise, it rotates. If I click on spindle stop, it stops. Spindle counter, this is clockwise, it stops. Press on this one, stops. This is counterclockwise, it stops. Clockwise, it moves. I can change like that. You see, this is how you move or you operate your machine. This is called machine control panel. These are called machine control panel. So it can allow you to do joke mode. It can allow you to do reference. It can allow you to teach in. It can allow you to do MDI. It can allow you to auto mode. It can allow you to do reset. Also, you have reset button. And then single block. Single block, when you're cutting a program, for example, you want to move it manually within maybe a block by a block. We go by single block. I can open a program here, maybe for example a simple program here. Then let me open this program I've written. Then you click here, open. This is a program I've created, a simple program. If you move like this, this is a program. For example, I'm moving, go to home, the export of them at the same time, the tool number, the tool offset, G96. I'm making sure that I'm limiting my spindle speed to 3000, M08, all this. So if, for example, I wanted to run that block only, I use this single block instead of auto mode. So when I press cycle start, it goes direct to where the block is. And then I require it. It is required that I click it every time so that it go to the block. For example, it's now auto mode, but I want to go single block. Automatic mode, single block. So when I go to that block, I click cycle start. It will go to that block automatically. I click again cycle start. It will go to the block directly, like that. So it goes block by block, block by block. We call it single mode operation. Single mode operation. If I click again, it goes to that point. Remember? So it is called single block operation. Then, in case you have not done setup, for example, this one I have not done setup, the tool has collided. So what you do, you just click reset button and then go to joke mode. Click reset button, go to joke mode, press Z positive, go to Z positive, like that. Click Z X, go to also to Z positive, like that. So it goes away, then remove the error. So this is how you operate a Siemens controller. Let's go next. Next is about program operations. So how do you write a program? Other program operations, you can use what you call program button. Then you can do a verify program, single block or dry run, auto mode, program execution, then editing. Let's go to our controller. So I'm assuming this is the controller. First of all, let me move it away. For example, let me go home. I'm away from that point. Let it go away first of all, and then I will load the tool. I'm assuming I put it home. Also X. Let me go home first, like that. And then I want to put a tool here. I want to put a tool here, tool management. I want to put a tool on my controller. Let me double click on this one. I change this tool. I'm using this tool. This is a DNMG 55. Then okay. Then from this tool, okay, like click. Then I say add to turret position number 1. The tool comes here, as you can see. Then I click OK. Okay, from this. So this is the tool I've put on tool number 1. This is the tool I've put on my magazine. As you can see, this is the tool. From there, I can also create a tool from offset. This offset, I can now this one press this, click reset button like this, then go to offset. So this is the button I've put. So this one allows you to move across or put the tool as you want. So you can click on reset button here, then go to operate. Yes. Well, let's remove single block first, then remove this. You can remove this one, jog mode, and then go to offset. From offset, we want to check this roof, this tool number 1, it is 4. You can select this tool, you move across this up, down, this one for selecting. Then I can say select this tool. For example, I want to check that the tool we are using is the right tool. I want to edit the tool. You can see, you can now tool measure, you can check the edge, you can delete the tool, you can unload the tool, you can delete of them, you can select for the magazine, you can get a new tool. For example, all of them, these are tools are here for roughing category, for finishing category, for plunging, that is grooving, that is parting off and grooving, for threading tool, for button tool, that is round tool, that is arrow tool, roller tool. All of these are here, so depending on which one you want. For example, if I want to create a finishing tool, I go down, then I click OK. It will give me a category. Maybe I can say, let me check this one to VNMG 160404. So I'm assuming this is a tool. Then I move across like this. We press enter first, move across like that. Check the radius. Radius is 0.4. You press this enter button. You go down like this. So it is this is if you click select this one, this is the direction. So this my tool is like this. These are the direction of the tool. That's how the tool is. It shows you the orientation of the tool. So my tool is pointing downward like this. So I can create a tool. Then maybe for example I can say this tool. Even I can edit this one for example. I can edit this tool. I can say from my magazine. I can say new tool. Or edit the tool, for example, this tool or new tool. I can say using the roughing tool. I go up here, say roughing tool, select or click OK. Then I can edit it. Roughing tool, for example, say DNMG 110304. You press this input button, move across one by one. There, put the radius 0.4, 0.4 input. For example, here, move across. And accept even the angle. For example, angle is -3. This angle also -95. So I can put angle -95. Okay. This is how you create a tool. And then from there, you can now measure the tool. You can measure the tool. So you can come here to a program. For example, I want to change this tool. Can press enter. Then I say I want to create a new tool from here, from the magazine. So how do that? I can say how can you put the tool here? I want to select the tool. I'm doing editing. I can now pick my tool, or I can search the tool in case I want to do. So this one allows you to edit the program or even add the tool for the what you call offset. So this is offset. And then we have what we call machine. Machine is now the display mode for your machine, which in case you change any mode here, it applies here. So it normally called M. Then you have jog. So in case I want to TSM or measure, make the workpiece, for example, or measure the tool, for example, or they change the position, for example, I can go to measure tool, then I say manual or automatic. If it is automatic or manual, click on manual, then I can say now select the tool. Maybe I can change the tool here and pick the tool, maybe number 1, I can pick number 1, for example, like that. Or I can say select from the magazine. If I don't want that, for example, I can now select from magazine, and then I come and pick that tool, and then say in the magazine, it picks that tool. Then from there I go and do the setup. Or I can come directly and I'll do a rapid adjustment where I want to pick from this at my 0 point for this part, and also maybe workpiece. I can check the workpiece material, stock size. I can check the stock size here. The stock size is diameter 80. You see that when I'm now setting this, I can come here and then put diameter 80. Sorry, I move down a little bit down here. Then I can put 80 as my diameter. This, and then I click set length. So it has determined the value of the X for that case. So you have, that is how you operate your machine. Then here I can say it is 0. I can say input and then say set length once the tool has touched. Or even I can say Because if I'm not using diameter, I can say that is where 0 point is, can say input, it says set. So it gives me the value for that part. Or I can use the diameter way to set my workpiece, then say set length at that point. So it depends on how you are doing it. And then I can say save the positions. For example, I say save the positions. I can come to Z, also save the positions where it is. Or now select the tool. That's how you do it. Then from there, we able to create a program. This is a program. When you click on program, it's when you're creating a program. If you want to create a new program, you go to program manager and then click new part program. Then write there maybe your name, for example, maybe test 2, for example. Click and this enter and then OK. Then from there you can now start writing your program G291 blah blah. You start maybe entering your program G00, G54, G90. For example, this is manual way programming your machine, or maybe the G90, and then you go maybe you are using T1, let's say T1, maybe M03, let's say 460, then D1 like that. This is for Siemens 828. So you can get this program manually one by one, but you need to understand the G code. What is the meaning of this G code? The meaning of this, there are various G codes you need to understand what do they mean. Like 00, it is a rapid positioning. The tool moves rapidly without cutting. If it is G01, it is the linear interpolation. The tool now start cutting. This one is now where you need to use a feed rate when you are cutting it. Either you are doing chamfer, you are going vertically or linearly or horizontally. This you normally use G01. If the tool is you are cutting an arc, going clockwise or anti-clockwise. If it's clockwise direction, you're using G02. But if it's anti-clockwise, you're using G03. Then if you are dwelling for certain time, you can use either G04X or G04P, depending on your machine. Then high speed for high speed positioning, you can use G05. Then G3 and G2 for thread cutting. So these are some of the G codes you need to understand before you select you start now programming. Like G17 is you are doing what called XY plane selection. You are selecting the plane. Normally this is the default for milling, 3-axis milling machine. They normally use G17. If it is turning, this is the common in turning, 2-axis controller. We normally use G18. G19 is normally less commonly used, depending on how you have selected or oriented your machine. This is on the plane. You can also select the units. So the units like G20, it may depend. If you're using a Siemens controller, you may find the class A, B, or C that are using either G70 instead of using G21, or G21 for metric units, which can be also G71 for Siemens controllers. Then G40, you call what tool radius compensations. You are cancelling any tool nose radius compensation. But if you're using G41, you are compensating the tool nose radius towards the left. But G72, you are compensating the tool nose radius towards the right. And then G43, you are compensating the tool height, the tool offset length. Then for 9, you are cancelling the tool length offset. You call tool length offset. Then the G54 to 59, you are selecting the work code system. We have G54, 55, 56, 57, 58, 59. Then G90 is absolute programming and G91 is incremental programming. So it depends which class of A, B, C you are using for Siemens. Somehow other class like in Siemens, you can use G90 to do taper turning or straight turning or chamfering in Siemens. Even G91. So it depends on the actualization of the code. Then like Siemens 808, Siemens 802 and Siemens 810, in case you are using the Siemens controller editor, you can transit it to ISO mode. For example, if I put G291, initially I'm activating that I'm using ISO direct programming instead of using G290. For example, for corner radius, you can use G50 for automatic corner radius and G51 for cancelling or for automatic chamfer radius compensations. That's a basic for Siemens. For M codes are normally standard for like M03 starting spindle in the clockwise direction, M04 starting the spindle in the anti-clockwise direction, M05 stopping the spindle, M19 normally is spindle orientation. If you want to fix the spindle to a certain point, you use M19. Then M08 coolant on or M like that. Then M40, you are changing the gear of the machine. For example, you realize when you're doing homing on this machine, if I'm doing machine mode here on the jog mode, then I'm using TSM, you might find here now the gear mode here, it is auto mode. So that's how you can pick your gear mode for Siemens. Then gear range normally ranges from M41 to M45, depending on the gear you want to select, so that it can give you the accurate torque and the speed for cutting the work. Then for coolant control, like M07 is normally mist coolant on, M08 normally flood coolant on, and M09 is you are putting off the coolant. Because these are PLC control, you are switching on the pump to switch off, or switching on the pump or switching off the pump. Then we have what we call the program controls for M00, that is program stop. This is unconditional stop. In case you have put it, the spindle will stop, and then you actualize the automatic button to proceed. Then M01 the same for optional stop. M02 program end. Normally this one I used in the program end, but it doesn't rewind to the start. But the common one is normally use M30. For example, in the here program, you can see if I click on this program, you're able to see. Let me open a program here I've created. Before you go and create a program, you can able to see. Let me open this. You're able to see at the end of this program, at the end of this program, let me go down. These are a very long program. You can use page down, page down. I want to go page down. You see M30, it is end of the program. If I go up like this, you see M05, you am now, it is used at the end of the program. Let me go back, up, page up. I want to start on the page up. You see the program, how it look like. Normally I have initialized this. I have initialized this one. If I put this G291, it means I'm using ISO. Then here you see I'm using G290, 95, 64, 71, and 40 for that. Then roughing, homing the machine. I can home the machine first of all, G0. Then I want to remove Z first of all, Z, and then I want to move first of all this G75, and then I put G0, Z0. So homing the machine first, M01, then tool number. For example, I can put here tool number, I can put here D1, and then remove the lower one. So depending on the controller, like that. So I can control this. You see now when I'm starting, at the start here, this M08, which means I'm telling the machine to start coolant on. But here initially the spindle is started with a limiting speed of maximum 3000, like that. Then I go down. So if you go down there, you will find I've put M05. I've put M05. You can see M05. That is stopping the spindle. M09 stopping the coolant, and M30 stopping the program. But remember, I can leave this. I can leave this one. Also, I can leave this. And I use only this so that it can do the whole work for that program. We call it M30 because it will stop the coolant. At the same time, we stop the program and rewind to the start. Then you have M17. You normally use for sub program. Other machine uses M98 and M99. M98 sub program and M99 end of the sub program. A program within a program. A movie within a movie. Then we have M06 for tool change and M061 to M68 for tool clamping, depending on your machine you are using. So these are the codes you use. For ISO code, for example, an example of ISO codes, if you want to activate your ISO code in Siemens controllers, this is how you do it. At the beginning of the program, you have to initialize G291. As you can see here, it activates the ISO dialect, which means because Siemens control has the Siemens contour editor, its language and ISO language. In case you are not conversant with Siemens language, you can now use the ISO language you know from across, so that you can now activate it initially before you use it. Then if you are using metric, normally use G21. Then selecting the plane, if it is milling, you are using G17, but if it is lathe, you use G18. Then G90 is absolute programming, but the Siemens you can also use AB. If it is incremental, use IC. But ISO you can use G90, and selecting the work offset number 1, use G54. This is how you initialize your G291 for Siemens controllers. Then you can now start programming your machine. For example, this maybe for example main program Siemens format. Normally it must have a .mpf format at the end of it. For the file format, it must be .mpf for Siemens controllers. So this is how you activate your program. As you can see, this is what we call a safety line. a safety line. You can see in my program, if I go up here, you will see my safety line. So it depends on how you write it, the safety line. This is the safety line I have put. This is the safety line. G, this, blah, blah, blah. So I'm actualizing my machine to use G71 because it is Siemens. Others you can use G21 to say it is metric, like that. Then I can say the plane I'm using G18, for example. So you can actualize your machine to follow that sequence as you want. Then tool and workpiece setup, you can use this T1 and M06. That is automatic tool change. And then this one means you are now trying to compensate the tool height. As I said, you remember I explained the meaning of G43 tool height of this. I can pick this tool height, for example. I can copy this tool height. I can come to my program here. I can go to my program here, for example, tool height here. I want to move down up here. Then I say, for example, enter. I can paste here. I can put here G43 H1 maybe Z150. So what does it mean? It means I'm compensating my tool height at position number 1 for tool number 1 with a Z height of 150. So this is how you can do it. Then spindle speed, yeah, your spindle speed, you can also actualize the spindle speed either to move clockwise, then rapid move positioning of the tool, like that. Then machining operation, now you start putting point where you're cutting. The point where you're cutting, you require to use G01 with a fit rate. That's why you see G01 has a fit rate. This is rapid movement. The tool is now moving rapidly because it's milling. Go to this point. They now go deeper, 2 millimeter. Start cutting using a fit rate of 100. Then now go to this point, point 1, point 2, like that, as it moves. When it finishes, it races up. It retracts from the workpiece to a certain height, like that. Then at the end of the program, you have to put a save point. Now move to a save point rapidly to a save point for Z if it is milling. Then stop the spindle and then stop the program and rewind the program. So this is how you can put ISO direct in your Siemens controllers. If you are using G290, this is how it's normally done. Because it already by default, normally Siemens is by default, so you don't need to put G290 at the start of the program because it is by default. This is how you write it. You may using now D. You find Siemens are using now D. If my program, you can see here, initially I'm using D here for the tool. You can check tool here. This I'm using D here, which means it is Siemens controller. So that is how the language is. Then it has different way of writing. For example, the program for truncating or turning operations for milling is normally cycle 95 for Siemens 828, 95 or 97. So it depends on how you're doing for your contour editing. So you find this language is not ISO, but it's Siemens language. Then you find it has advanced like Siemens 801 for symbol drilling, which is same as writing G91. But for machine like Siemens has, you can use G91, sorry, G81, G3, G75, G76, G73, like that. Or you can use G76 for thread cutting in lathe, but if you are milling, you're using pocketing as Psycho 76. So these are language for Siemens. They are different as from the ISO language. So you need to initialize your parameters like that. You need to put all the cycles that is required. But that is how you program in Siemens. Then you're able to understand the difference between ISO dialect and Siemens dialect. If it is 808 and 802 or 810, you are using Siemens language which is native as G290. But if you are changing to ISO, you will be using G291. They are not so much different, but you need to understand how you use them and how you can align so that it gives you what you want. That is how you maneuver around Siemens controllers. So this is what we call the Siemens controllers. Then also it has the contour editors. As I said, these are contour editors. If you are writing a program, for example, as I said, I was writing a program here. Let's say go to this test. I open this. I was writing this program when I was trying to demonstrate this. So you need to understand how to write this program in Siemens. So just like as the other machines, you need to also to understand the meaning of the operations, the meaning of maybe tools, how to select the tools, how to identify points when you are programming. In my next episode, I will go to show you how to identify the points before you start writing the program. That is very important. If you are writing it manually, to understand how you're able to execute the program in your Siemens controllers. But in case you're using Siemens controller, it has all this. You have drilling, click on drilling, then you click the maybe deep hole. You now start putting here your operations. If it is turning, you click on turning. You select if you are doing stock turning, groove of undercut or threading or cut off. If the stock turning external, it has all this, so you just input the parameters. If it is contour turning, also the same, you go to contour turning, maybe stock removal, you now start putting all the contour you want. If it is milling, same way you can do that. Then variance, you are putting the stock simulation, you now do a simulation, then you can click execute, run a program. For example, if I click on this program manager, I want to open a program. For example, this one, say open this. If you see this program is a Siemens language, you see this program is a Siemens program. If you move like this, is a Siemens program. If I want to do an execute, I can write here, cycle start this, and then I want to do a simulation here without cutting, and then I'll click this cycle start. If I want now to cut it. So this is how you put your machines. I can also do program levels, check the program level, timer, basic. All these are the functions you can now use in Siemens controllers. Then for you to transfer that program, if you have used maybe a CAM software, you have programmed your CAM softwares. Maybe for example, if I did my program from this CAM softwares here, let me show you. If this is the program I did program for this case, I want to transfer this program there. Whatever I'll be doing in the software should be done in the controllers or the controller I want to use. For example, if it is doing here turning, if I click here turning, whatever it is doing here is the same way. I will now transfer this program machine so that it can now start cut what is required in the so this is called CNC turning. So this one will give me a G code. This is here now. For this program, you see this is a G code. I've put a G code, I've recreated this one, so I can now save this program. As I said, at the end of the day, it must have a .mpf file. Siemens 828 or 802 or whatever. So you can put all this program in your machine. It can cut as what you want. So these are what you program in your machine. For example, I want to explain this one in details, but I'll show you what it means. I'll guide you what it means. These are program I have generated. If I want to program to write this one, I can now save this. Let's say maybe ISO save as this. I can go to, let's say, downloads. Let me save there. I can click here .mpf. Then I can say save. So which means I put my program in a flash. I can come to my machine here. I can go to program. Maybe for example. Load, for example here load, you can see load from the drive here. You can now load from the drive or from NC or from USB. If it allows you to load from the USB, so you can now load the program from the USB. You just put a USB here, then you load your program from USB and ensure it is .mpf. So this is how you can now create the program in your Siemens controllers. If you are using Siemens or you are using normal way. So remember like this, this is a program for this is a program for Siemens. All these parameters are put as per required. So you need to understand how to write it, because it's a program that is normally used in Siemens language. So if you don't know how to use it, you now must understand how to use the contour editor. Or if you don't know how to use this one, actually, as I said, use the ISO dialect, where you initialize using GIS 291. Then from there you now start writing your program. Only on Siemens 808 and Siemens 820, 802 and Siemens 810. I think Siemens 828 has advanced, so you can also switch from between ISO and other controllers. So this is how we have done. We have done our program starting the procedure, manual operation, program operations, also tool management. So tool management, you need to how to understand the tool and safety procedures. What are the safety criteria you need to understand in your controller? First of all, you need to have PPE, right? PPE when you're operating these machines, and then the safety guideline is on your program. You're writing the program. These are the safety approach, and then the cutting program, and then there the safety retraction. It has 3 parts. A program has 3 parts. Safety approach. Normally, you need to know the safety approach of the program, the cutting program, and then the safety retraction. Then another safety is you use emergency button and reset button. In case of any emergency, you have to press a safety button or emergency button or reset button. Another safety criteria in CNC milling or turning, you need to understand the workpiece size. So you don't just program workpiece size you're using. So it must be a correlation with what you are doing. If I go to this controller, for example, this is now an actual machine. this is the actual machine. If I want to go up here, let me go to this workpiece. I want to show you the workpiece here. This workpiece. So this is the stock safety part of it. So I'm cutting to 70, but there's a holding of 1 or 2, so meaning it has a safety guideline. As you can see, ZA, I can even put 0, for example, which means I'm starting from 0, and then ZB, where I'm cutting to, and then Z1 is where I'm reaching. Even I can increase where I'm reaching. For example, I can say I'm reaching even 130, for example, and then I say accept. From here, accept, I'm able to do a simulation of this program. I click now, do a simulation, auto start, and then I want to change the mode, maybe the mode, click here, cycle start for simulation, so that you see how the program is running to understand how to maneuver between each point before you now start cutting your work. If I click here, cycle start or program start, so it can now start doing a simulation on what I have done. Yes, I can do side view also for this part. Cycle start on this. This is still running. You will see the program starts running here. Sorry, just wait a little bit. Reset button, the cycle start, and the program variance. You can change the variance. Click here, reset button, and then the blank. I can change the blank here. Can click simulate, and then cycle start. For this case, let it load the program. Then we go to cycle start, because we are now doing simulation. It's not actual cutting, simulation. You see how the tool will be cutting. So this is how you program your part in Siemens controllers. Now you see it must start cutting, doing a simulation, so you can see how it will be cutting our part, giving us the program here. Once you feel it's okay, you can now start cutting. It is still loading. See loading here on the actual controller. I'm using the actual controller for Sinumerik. This is a Sinumerik for Siemens controllers. Okay, just a little bit. I think it's loading. So this is how you write the program. Let me go, and this is safety, and then we go to our tool management. As you can see now on our tool management, why is it taking time? For tool management, or access of the tool offset, or tool offset, and also measuring either using prop or manual way of measuring, keying the actual value and measuring. So I will show you how to measure the tool here. Basically, let me change it to jog mode, then TSM. I want to load maybe from a tool, select from the magazine. I pick this tool maybe into my magazine, then change here the spindle speed, maybe let me put 500. Gear automatic, then I can change the direction, plane, machining plane, work offset, I want to say G54, work machining plane G18, then I can click cycle start. From there I can now say measure tool. From measure tool, click manual measure, example, and then you go to maybe your X, your Z. You can go to point where it is. If the value is 80, you measure, you put the actual value 80. And then you come to Z, also you put 0 input, then you click set length, go back to a point, go to work offset measurement, click work offset G54. You can go to where G54 is, for example, in manual measurement, for example. You can come here, then put value for Z, 0 input, then say set work offset. This is how you set your tool. Once you finish doing that, you can now go to your program. Then from their program, you can now start cutting your program as you wish. In case of anything, you can change even the safety part. I can say maybe 82. I can go down 100. Then from there, if it's okay, now tool number 1. I can now click here, execute. Then I can let me change the display so that you can see. This is the machine. I can close the door. For example, I can change the display, and then I can click jog mode here or reset button. Sorry, reset button here. I want to move away because the speed is still rotating. Then from here, click cycle start. So this one will give you the operation what it now start cutting. Once you do that one, now start cutting.